Welcome to today's lesson on linear proportional relationships. We're going to be working with equations, tables, and graphs. I'm going to go ahead and share my screen. Okay, so our TEK for today is 8.5a and 8.4b, and our lesson target is I can represent linear proportional situations with tables, equations, and graphs in the form of y equals kx. So we're using that y equals kx equation. Our essential question is, what do you look for in a table to decide whether the relationship is proportional? So we haven't yet talked about this, so we're not going to be able to answer it at the moment, but by the end of the vocabulary, we will be able to answer this. So our academic vocabulary, our first word is proportional relationship. So that is a relationship between two variables where their ratios are equivalent. Remember, ratios are comparison of two things. Ratios can be written with a colon, the word to, or a fraction. So in math, we mostly use the fraction, or that's what we have been doing. One variable is always a constant value times the other. So the equation for proportional relationships is y equals kx. Then for direct variation, the relationship between two variables in which one is a constant multiple of the other. That is the same equation, y equals kx. So we can think of direct variations as proportional relationships. Okay, for constant and proportionality, it's the constant ratio of one variable to another that is proportional. So we learned that constant is represented by the letter k, and it's equal to y over x. So we manipulated that original equation that we had, k times x is equal to y, and we moved the x to the other side by dividing because we had to do the opposite. And so once we did that, that's how we got k is equal to y over x, or y over x is equal to k. And then ordered pairs is just another word for coordinates or points. So it's two numbers written in a fixed order inside parentheses that represents the location of a point on a coordinate grid. So if we look at the proportional table, we can see that we have over here 2, 6 is an ordered pair. Then we have 4, 12. The origin is that first point. It's a special point. It's 0, 0. So it's the place or point where something begins. And of course, in math, 0, 0 is the origin on the coordinate plane. Then we have rate of change, which is a rate that describes how one quantity changes in relation to another quantity. So an example of that is running 70 yards in 10 seconds. Unit rates. It's a rate for one of something. So this is written as a ratio with a denominator of 1. An example, running 7 yards in 1 second. So unit rates are always per one of something. So if you think of the grocery store, maybe when you're buying something like fruit or produce, you pay per pound, right? So it's 50 cents per pound. Now with inflation, it'd be a lot more. But then also when you're driving or when you're in a car, there's speed limits, right? So we have 70 miles per hour. That is per 1 hour. So that is a unit rate. And lastly, our vocabulary word is slope. That's a number that describes both the direction and the steepness of a line. So slope, we're going to use the letter M to represent. And slope actually, along with unit rate, rate of change, and concept of proportionality are all the same thing. So despite slope being represented by the letter M, slope is still the change in y over the change in x. So we'll talk about that a little bit later. Okay, we're going to get into our first we do. So it says that Marco earns $36.50 per hour as an accountant. Show that the relationship between the amount he earns and the number of hours he works is a proportional relationship. Then we have to write an equation for the relationship. So this problem gives us our constant of proportionality because it gives us our unit rate, that $36.50. Okay, so our equation is going to be in the form of y equals kx. So of course, our equation is going to be y is equal to 36.50x. And I'll go ahead and add the dollar sign since we are talking about money. So we can see that the hours worked is our x value, and that means the amount earned is our y value, right? So we have one ordered pair already filled out for us. That's 1, 36.50. So what we're going to do is plug in each of the x values and multiply it with the 36.50 to get our y. So 0 times 36.50 is 0. 2 times 36.50 is 73. 3 times 36.50 is 109.50. If you use the calculator, it would say 109.5, but remember we're talking about money, so that's why it has to be 0.50. 36.50 times 4 is 146. Okay, then we have our next we do problem. So we have a table again. This time, though, we have mixed numbers. So mixed numbers are fractions and whole numbers, right? So we have 1 and a half. So then we have 3.5. And lastly, we have 7 1/4 and 362.5. So to turn these into decimals, we're actually going to add them because when you have a whole number and a fraction, you're adding them. So if I convert 1.5 into a fraction or into a decimal, it's going to be 1.5. Then 3.5 is going to be 3.5. And then 7 1/4 or 7 1/4 is going to be 7.25. And then, of course, we have 362.5, which is 360.5. So I'm going to show you on Desmos, just one example. I'll show you the 1.5. We're going to type in 1 plus 1 divided by 2, and that's what gives us the 1.5. Okay, so it says the table shows the distance between various cities on a map in inches, X, and the actual distance between the cities in miles, Y. So first we have to figure out, is the relationship proportional? So we know that proportional relationships use K is equal to Y over X, or have a constant of proportionality, right? So over here, they already labeled our Y and our X. What we're gonna do is we're gonna figure out what is our constant of proportionality. So we have our Y 75, so we have 75 over our X, which is 1.5. Then for the second ordered pair, we have 175 is our Y, 3.5 is our X. For this third one, it's 200 is our Y, 4 is our X. Then we have 250 is our Y, 5 is our X. And lastly, we have 362.5 is our Y, 7.25 is our X. And so of course, we're going to divide. So if we divide 75 divided by 1.5, we're going to get 50. And then if we divide 175 divided by 3.5, we're going to get 50. If we divide 200 divided by 4, we're going to get 50. If we divide 250 divided by 5, we're going to get 50. And lastly, if we divide 362.5 divided by 7.25, we're going to get 50. So because there is a constant of proportionality and because all these numbers are the same, our answer is yes, the relationship is proportional. And so I realized I forgot to answer our essential question. So I'm actually going to go back, right? So how do we know if a table is proportional or not? I answered it just now, if there is a constant of proportionality, right? So in this problem right here, or in this table right here, we have our time is going to be our X value and our distance is going to be our Y value. So over here we have 6 over 2, which is 3. Next we have 12 over 4, which is 3. And lastly, we have 18 over 6, which is 3. So as you can see, our constant of proportionality is the same. It's all 3, right? So when it's a proportional table, there should be a constant proportionality, and that number is the same. But if we try to do the same thing with this non-proportional table, so the first one we have 4 over 0, which is 0. Second one we have 10 over 2, which is 5. And then we have 16 over 4, which is 4. So over here you can see that there is not that constant of proportionality. But remember, the constant of proportionality is the same thing as the slope. We just have to use a different equation. So again, I'll introduce that later on once we get to it. Okay, so back to this problem. Now we have to write an equation that describes the relationship. So we know that our constant of proportionality is 50, so our equation is going to be y is equal to 50x. Then the next part of it is saying the distance between Jacksonville and Daly City on the map is 9 1/8 inches. How far apart is the city in miles? Okay, so first we're going to turn the 9 1/8 into a decimal. So we're going to add 9 plus 1/8, so that's going to be 9.125. Then we're going to use the equation that we came up with, which is this y is equal to 50x. And we're going to think, do we solve for the x or do we solve for the y? Well, inches. Inches, according to our table, is our x, right? So we're actually solving for our y because we have our x. So what we're going to do is we're just going to plug in that x value. We have 50, and then we have 9.125. And of course, when you have 50 and x, you're multiplying, right? So that's why we're going to multiply 50 times 9.125. And that gives us 456.25. And if you look, our y is in miles. That's our unit. So that's why our answer is going to be in miles. And then the last part of this question is asking about San Diego, California and San Francisco, California are 550 miles apart. If you're putting these two cities on a map, how many inches apart would they be? Okay, so we're going to use that same equation, y is equal to 50x. But this time it gives us miles, right? And miles we know is our y. So this time we're going to plug in our y value. So that's 550 is equal to 50x. And when we're trying to solve for the x, what we're going to have to do is, because we know we're multiplying, we're going to do the opposite to move the 50. So the opposite of multiplying by 50 is dividing both sides by 50. So 50 divided by 50 is 1. So we have x is equal to, and then 550 divided by 50 is 11. So we have 11, and this time our unit is going to be inches because we solved for the x, and we know that x is in inches. So we're switching gears a little bit. So now we're working with graphs, right? So we were working with tables, now it's graphs. So this problem says a person riding a bike burns 640 calories every 2 hours. Which graph shows the relationship between the number of bicycling hours, x, and the number of calories burned, y? Okay. And then, of course, since we know that this is a proportional relationship, the reason that we know that is because all the graphs go through the origin, right? So it goes through the 0, 0. So that's how we know it's proportional. Okay, so what we're going to do is we're going to figure out which number is our y. So if we look at the y-axis, we can see it says calories burned. So that means that the calories burned is our y. Also, it says it in the problem, number of calories burned. If we look at our x-axis on the graph, it says time in hours, right? And so then it also said number of bicycling hours, x. Okay, so now we can plug in the numbers. So our y value is going to be 640. And that makes our x value 2. So if we divide 640 divided by 2, we're going to get 320. And from here, we can write our equation, which we're used to doing, right? So we know our equation is going to be y is equal to kx in that form. So then we have y is equal to 320x. So from here, to figure out the correct graph, I'm actually going to make a table. So we're going to go back to making a table. And you can see that all of the graphs have the numbers 1, 2, and 3. So I'm going to choose numbers that all of the graphs have, right? So I'm going to multiply because we have our x values. We're trying to solve for our y. 320 times 1 is 320. 320 times 2 is 640. 320 times 3 is 960. Okay, so we're going to look for which graph has these numbers. So A, looks like 1 is in between, when x is 1, our y is between 200 and 400, which is what we need. Then for 2, it says that on the graph, it says that our y value is between 400 and 600, but in our table, we need it to be 640, so it can't be A. Then for B, for 1, again, the graph is in between, for the y values in between 200 and 400, so it could be 320. Then 2, it's in between 600 and 800, so it definitely could be 640. For 3, it's in between 800 and 1,000, so it could be the 960. So it could be B, but I'm going to look at C and D. Okay, so for 1 over here, our answer for our y is less than 200, right? So it can't be C because we need it to be 320. For D, 1 is way too big. Our y value is 600, and we need it to be 320. So yes, B was our answer. And then our last we do. So first, I'm going to show you guys how to do these problems, by hands, and then I'll show you on Desmos. So we have to find the unit rate and the slope in the equation, right? So we know that this is a proportional relationship because, again, it goes to the origin. So we can just choose a point on here. We have 2, 2. We know that this first 2 is our x coordinate. We know the second 2 is our y coordinate. And we can use the equation k is equal to y over x, right? So our y value was 2, our x value is 2, so that's equal to 1. Okay, so we know that our unit rate is 1. Another way to solve that is, remember when I said that slope is the same thing as our k? So to find the slope, it's the change in y over the change in x, right? So for slope, you need 2 points because you're going to subtract y2 minus y1 over x2 minus x1. Okay, so we have this 0, 0. We have the origin, so we'll use that. And now I'll label this x1, the 0, the first 0, then y1, the second 0, and I'll label this x2, y2. So we have our y2 is going to be 2, our y1 is going to be 0, our x2 is going to be 2, our x1 is going to be 0. So we're going to subtract. 2 minus 0 is 2. 2 minus 0 is 2. 2 divided by 2 is 1. That's also how we get the unit rate or slope, which is why I said that constant proportionality is the same thing as slope. The last way to do this is to do it the change in y over the change in x, right? So visually, we can see that our change in y is 2 because we went up 2 units up. Then our change in x is also 2 because we went 2 to the right. So that also explains this 2 over 2, which is 1. And of course, because we have our unit rate or a slope, we have y is equal to 1x. Okay, so going back to this problem, I'm going to find the answer on Desmos. So all we need to do is type in that equation, y is equal to 320. Okay, so I'm going to erase this. We have y is equal to 320x. And you can see that it graphs an equation, right? It makes a graph, but none of our graphs from that problem looks like this. So that's why we have to double check by making a table. So we click on the settings, then table, and you can see that this table has a 0, 0, 1, 320, 2, 640. So of course I can just change it from -2 to 3, right? And that was a 960. So this essentially matches the table that we made right here. And then once we have the table, of course, we have to match the numbers to the graphs. Okay, for this problem right here, we can make a table with these 2 points, 0, 0, and 2, 2. So I'm going to show you what I mean by that. So I'm going to erase this. To make a table, I have to go to the plus table. So I'm going to write the 0, 0 on the first line, and then the second line 2, 2. So I can use either the proportional relationship equation, which is going to be y1, because over here you can see that we have y1, and then the tilde, the squiggly. Oops, I did not mean to erase that. Okay, there you go. So the tilde, and then we're going to use k, because that's our constant proportionality, and then x1, because you can see x1 is right here. Okay, and you can see our k is 1, right? Or our constant proportionality is 1. Another equation I can use is y1 tilde mx1. Okay, so this is the equation for non-proportional relationships, right? It uses the m instead of the k. And also we have another letter. That letter is our b. And the reason we have b is because that's the y-intercept. So that's where the line crosses the y-axis. Because in a proportional relationship, the line will always go through the origin, as you can see right here. This is the origin. But in a non-proportional relationship, it might not go through the origin. But as you can see, our m is 1, so the k and the m match. The b is 0. So that's how we know it is proportional, because our y-intercept is 0. So that is all for today's lesson. Thank you so much for following along, and see you in the next one.